All right, number 12 says the mean incubation time for a type of fertilized egg kept at a certain temperature is 19 days. Suppose that the incubation times are approximately normally distributed with a standard deviation of 1 day. Complete parts A through E. So first we want to draw a model that describes the incubation times of these fertilized eggs. So we're given the mean is 19. So if I draw a bell curve, my mean in the middle would be 19 days. And then my standard deviation is 1 day, so we would go out one standard deviation. That would be 20, 21, and then 22 would be up to 3. And if I go subtracting 1, this would give me 18. Subtract 1 again, that would give me 17. Subtract 1 one more time, that would give me 16. So this will be roughly our numbers for our bell curve. So we're looking for a graph that represents that. So in the middle they got 22. Our mean is 19. So this one looks good. So the only one that looks like it matches the information is going to be the third option, which is B. We're going to find and interpret the probability that a randomly selected egg hatches in less than 18 days. Okay, so since this is approximately normal, we can actually use the empirical rule. So the empirical rule gives you a breakdown that this is 34%. So the middle is 68%, and then this was 95. So between these two numbers, one standard deviation was 68%, which divide by 2, you get 34 and 34. These are percentages. And then between 17 and 21 is 95. The difference of 95 and 68 was 27 when you subtract those. We're subtracting because we already counted the middle 68. We're just trying to find these two pieces. So that gives you 27, and when you divide 27 by 2, that gives you 13.5. So these percentages are 13.5. And then if you go one more standard deviation out, this was 99.7, and again, if you subtract these two, because we already have up to 95%, we're trying to find these sections, that gives you 4.2. Is that right? 4.2. We're going to divide that by 2. I feel like I'm off. 95, 99.7 is 4.7 actually. Yeah, that's what it is. And that gives you 2.35. And then the last to make up that 0.3 is 0.15 when you split it up. So we can use standard normal in the chart, but we can also use our prior knowledge with the empirical rule. So less than 18, so that would be here and left, would be these three numbers. So that would be the 13.5, 2.35, and the 0.15 is this left area. Okay, so again, if I know that this is 50 plus 84, sorry, 50 plus 34 is 84. So this whole, it's easier to count this part. This is half from the middle to the right. This is 50%. This is a 34. So you do 50 plus 34. That gives you 84. That's the part we don't want. If I take 84 from 100, that gives me 16. So 16% or 0.16 is going to be the area to the left of 18. If we did that with StatCrunch, you should also get 16, but Stat Calculator's normal. Area to the left, we're going to do mean 19, standard deviation 1, we want the left of 18. You see you get 1586 when we round to 4 decimal places. I guess I can still use the 1586. It should also take the 16 approximately normal. Let's just double check, 0.16, but they want 4 decimal places, so it may not take it, but let's just see. They take it. So you can do the approximate normal, you can do the exact. The computer should be programmed to take both. Interpret the probability. So what does this mean? So it says on average, the average proportion of the way to hatching of all fertilized eggs in the past 18 days is, in every group of 100, blank eggs will hatch in less than 18 days. If 100 fertilized eggs were randomly selected, blank of them would expect to hatch in less than 18 days. So 100 fertilized eggs, that's what we're dealing with. Not in every group. So if 100 fertilized eggs randomly selected, so this percentage that we just came up with, the 16%, we multiply that by 100 because that's just a chance of 1. Multiply that by 100, we would expect roughly 16 eggs because we're doing this 100 times. So we would expect about 16 of them to hatch in less than 18 days. We want to find and interpret the probability of fertilizing eggs that take over 20. So if I go over 20, it's the same proportion as less than 18. We're going to get 16. So this time, I'm going to say if we did the exact numbers, if we did the exact numbers with the StatCrunch, I'm going to show you that. It should be the same thing, the 0.1586, 0.158. 0.1587 when we round it. So let's say greater than 20, just to show you, same thing. 0.1586 when we round up 0.1587. So here I'm going to put in 0.1587. Same thing, it's just on the opposite end. Okay, and it accepts that as well. And then when we go to interpret this, if 100 fertilized eggs randomly selected, blank of them would be expected to take more than 20 days. This is one we're looking for. If I multiply that times 100, which is this probability, I move the decimal place 2 times to the right. That would give me 15.8. But what they want us to do is round to the nearest whole number. So that's going to round up to 16. We're still going to get the same number rounded, 16. All right, we're going to find and interpret the probability that randomly selected egg hatches between 17 and 19. Okay, so between 17 and 19. So here to here. I can just add up these two probabilities using the empirical rule. So the 13.5 and 34. 47.5. You can also, I just closed it, you could also use StatCrunch. When you do between, it will find between for you to show you the difference. Stat calculators, normal, between, the mean was 19, standard deviation was 1, and we want between 17 and 19. So it gives us 0.4772, and we are rounding to, what do we get with the calculator? 47.5, or 0.475 when I put it all in decimal, 0.475. Either one of those is fine. I like the empirical rule, so I'm going to put the 0.475. If you remember that, it takes both. And then if we do 100 fertilized eggs, I just multiply this probability times 100, which would just be 47, or round up to 48. So not every group. We're going to look at randomly selected, so that's going to give us about 48 would hatch between those two. And then, would it be unusual for an egg to hatch in less than 16 days? Why or why not? So less than 16 would be here. And we are looking at 0.15. Now, this is a percentage. So this is 0.15%. So as a decimal, move it over 2 times to the left. This would be 0.0015. This is less than the 0.05, which is our standard rule for being unusual. If something is less than 5%, it's unusual. And since the 0.0015 is less than 5%, that would be unusual. So the probability of hatching in less than 16 days is 0.0015. So it would be unusual since the probability is less than 5%.